Hey everyone, and welcome to today's explainer. If you're a student ready to unlock the secrets of coding and actually build your own computer programs, you are in the exact right place. Today, we're going on a mission to learn how programmers plan out their brilliant ideas using just 3 simple, magical building blocks.
Here's a super quick look at our game plan for today. We're covering pseudocode and flowcharts, followed by our 3 main blocks: sequence, selection, and iteration. Then we'll dive into a really cool case study and wrap up with a review quiz. So pay close attention, because those 5 quiz questions are waiting for you at the very end.
All right, part 1, pseudocode and flowcharts.
Before programmers write a single line of real code, how do they map out their ideas? Well, it all starts by asking, what exactly is an algorithm? Simply put, an algorithm is just a step-by-step set of instructions to solve a specific problem. Think of it like following a recipe to bake your absolute favorite cookies, or drawing up a playbook in sports. You need a clear, solid set of steps to get the win.
To plan out those steps, programmers use 2 amazing tools. First up is pseudocode. This is basically plain text using simple everyday instructions and keywords like input and output. The second tool is a flowchart. This is a highly visual map using colorful shapes and connecting arrows. Both are absolutely crucial planning tools to get our logic straight before we ever touch a real programming language.
Let's jump into part 2, our first block, sequence.
Sequence means that a program's instructions have to run in a strict, predictable order. They always flow from top to bottom. Let's think about calculating the area of a square to see sequence in action.
Step 1 happens first. We get the length through an input. Then, step 2, we multiply that length by itself to find the area. Finally, step 3, we output that area. Now, what's really crazy about this is what happens if you mix up the order. If you tried to do the multiplication in step 2 before getting the user input in step 1, the program would literally crash and fail. And that proves exactly why a strict sequence is so important.
Moving right along to part 3, our second block, selection.
Selection gives our programs the magical power to make decisions. It allows a program to check a specific condition to see if it's true or false, and then make a choice based on that. Think about getting ready for school. If it's raining, then you take an umbrella. That's your true condition. Else, you leave the umbrella at home. That's the false condition. Programs make choices exactly like this using if, then, and else statements.
So let's see how this works in real life by building a password security system. We'll set our secret password to let me in. Then our selection statement kicks in. If the password double equals the user's input, then output access granted, else output access denied. And by the way, that double equals sign, that's just the computer's way of checking if 2 things match perfectly.
And this brilliantly illustrates how selection looks in real MicroPython code. Let's say we're programming a microbit device. The condition says, if the microbit's light sensor reads a level greater than 50, then it displays a happy heart on the screen. It's actually choosing its path based on the amount of light in the room.
All right, part 4, the third block, iteration.
First off, the act of programming itself is an iterative process. That means it's a continuous repeating cycle. You plan, design, develop, test, and then review your code over and over again until it works perfectly. But iteration inside your code? That's where the real magic happens, saving you from typing the same instructions a million times.
Take the while true statement, for example. That is a type of iteration called a continuous loop. It tells the microbit device to repeat a task forever. In this case, it's continuously listening for an incoming radio message. If it receives the right signal, it flashes an image of a giraffe on the screen. So instead of writing a listen command thousands of times, one simple loop does all the heavy lifting for us.
Let's bring it all together in part 5, our case study. When you combine all 3 building blocks, you unlock endless possibilities. We use sequence to securely set up our radio channel in perfect order. We use iteration, a loop, to constantly listen for a button press. And we use selection so that if the correct button is pressed, then the secret message is sent. You can use these exact same blocks to build literally anything. Remember our password system from earlier? You could use a count-controlled loop, which is another type of iteration, to give the user exactly 3 attempts to guess the password before locking them out completely. Sequence gives the program order, iteration handles the repetition, and selection makes the choice. Together, they make a complete, brilliant computer program.
And finally, part 6, the review quiz. You've crushed it so far, and now it's time to test your knowledge. I'm going to read these 5 questions out loud quickly. Teachers, please pause the explainer right here so your students can answer. Question 1. What is the difference between pseudocode and a flowchart? Question 2. In our sequence example, what were the 3 steps used to calculate the area of a square? Question 3. What 2 possible answers can a condition in a selection statement produce? Question 4. What does the term iteration mean in coding? And question 5. In our password system, what was the password set to before the if statement checked for a match? Take your time answering those. Remember, by mastering sequence, selection, and iteration, you aren't just students anymore. You are real programmers now. So look around at the apps and games you play today. Which of these 3 building blocks do you think makes your favorite game work, and how would you code it differently?